All right, so for 4E, the very last lesson in Unit 4, so we're going to cover what is called arithmetic sequences. It is not arithmetic. It is called arithmetic. Arithmetic refers to something totally different. So we're going to be looking at what we call a sequence, a term, and what we call an nth term. So we're going to kind of focus on these first three problems first before we actually look at any vocab. So we're just going to be looking for a pattern among the following numbers. So the total pattern here, everything that's happening in this problem is called a sequence. So each individual value is called a term. So we're looking at the different terms in the sequence. So to go from the first term to the second term, from 1 to 4 here, what we're doing is we're adding 3. So to go from 4 to 7, once again, we're adding 3. 7 to 10, adding 3. 10 to 13, adding 3. So notice how we have a constant change. That constant change is what we're looking for. In order for it to be considered arithmetic, we have to be adding a certain value. So because we're adding 3, I'm going to keep going and add 3 more, which gives me 16, add 3 more, which gives me 19, and then add 3 more, which gives me 22. So I'm just going to continue the pattern in the sequence. So for this next one, now we're looking from 4 to 8. So here, what you could try to do is you could try to add 4. However, if I go from 8 to 16, that's adding 8. So that's not a constant change. So we can't add in this case. So what we have to look at is multiplying. So in this case, 4 to 8 would be multiplying by 2, then by 2, then 16 to 32. That would also be times 2. So we're just going to be consistently multiplying by 2. So if I multiply by 2 again, you get 128. Multiply by 2 again, you get 256. Multiply by 2 again, you get 512. Then multiply again, you get 1,024. Nope. Yeah, 1,024, 2,048, so on and so on. So in this case, this is actually what we call geometric because we're going to be multiplying. Which will be covered in a later unit. So we're going to be focusing on what we call arithmetic. So arithmetic is when we are adding or subtracting. Geometric is when we're going to be multiplying or dividing by something. So over here, now we're going from 7 to 2 to -3 to -8 to -13. So if you look here, we're going from 7 to 2. So that's -5. 2 to -3, -5. -5, -5. So we have a consistent arithmetic sequence here. So I'm going to keep subtracting 5, so I get -18, -23, and -28. All right, so looking at arithmetic sequences, it's a sequence that has a constant change for only addition and subtraction. So as mentioned up here, this would be what we call a geometric sequence. So this is not what we're looking for. So an arithmetic sequence has both an explicit and a recursive form. So we're going to be looking at both. So the change between both of those sequences is what we call a common difference. And we denote it just with a lowercase d. So we're going to look at the recursive form first. So the recursive form only lets you find the consecutive term or the next term. So if I have the first 3 terms, then I can find the 4th term, then the 5th term, 6th term, 7th term, 8th term. I have to go in order. So if I have the 10th term, then I can find the 11th, 12th, 13th, 14th, 15th, so on and so on. So you can't find like the 3rd term and then jump all the way to like the 20th term. All right. So we have the arithmetic recursive form here. So it's called A of n equals A of n minus 1 plus d, which is your common difference. So A of n represents your actual term value, and then the n minus 1 here represents your previous term. This is the most commonly misunderstood part of, I'd say, this entire lesson, the n minus 1 component. It just represents the previous term. So if I'm talking about the 6th term, the n minus 1 would be the 5th term. We're just looking at the term before it. All right, and then as mentioned before, d is just your common difference. So we're going to use the recursive form for these problems here. So given that a of n equals a of n minus 1 plus 6, I have a of 1 is 3, and I want to find a of 4. So I'm going to kind of really dissect this information to kind of break it down to see what it means. So right here, where we have plus 6, this is our common difference right here. So this is the rate at which it's going to change. So here we have our first term, a of 1. So our first term is equal to 3. So this is saying find the fourth term. All right, so you have to write these out in a very specific way. So a of 1, I know is equal to 3. So what I'm going to do next is I need to use the previous term to find a of 2. So I need to write the previous term, which is a of 1. So a of 1, and then I'm going to add 6. So I'm taking the first term, which is 3, and then I'm going to add 6, which gives me 9. All right, so now in order to write the next term, so now I want to find the third term. So now I want to find using the second term and add 6. So the second term was 9, and then I add 6, which now gives me 15. Now if I want to find the fourth term, so a of 4, now I'm going to use the previous term, so a of 3 plus 6, and I'm going to do 15 plus 6, which gives me 21. So my answer here, a of 4, is equal to 21. So my fourth term is equal to 21. So that's what we're looking for. So this lesson is really kind of a lot of writing rather than focusing on the mathematical concept, but some of these can get kind of lengthy in writing, so just keep that in mind. All right, so same idea here. So we are going to be consistently subtracting 5. Our first term is 45, and I want to find the sixth term. All right, so I'm going to start with a of 1, which is given to me, which is 45. So I don't have to go look for it, it's right there. Now a of 2, I want to take the previous term and then apply the common difference, which is minus 5. So I'm going to do 45 minus 5, which equals 40. Now I want to find a of 3. So a of 2 minus 5, which is 40 minus 5, which is equal to 35. So we're just going to keep applying this pattern. So now a of 4, use the previous term, which is a of 3, minus 5, which is equal to 35, minus 5, which is equal to 30. Now I want to find the fifth term. So a of 5 equals a of 4 minus 5, which is equal to 30 minus 5, which is equal to 25. And now I want to find the sixth term. So you want to keep going until you find that indicated term. So find a of 6. Now we're going to use a of 5 minus 5, which is 25 minus 5, which is equal to 20. So a of 6 is equal to 20. So as mentioned before, this is really, it's just a lot of writing, but the math itself is either adding or subtracting a certain number, a constant number of times. Okay, so I would say you guys try this one on your own. Or don't, it's up to you. All right, so a of 1 is 24. So my common difference up here is 7. And I want to find the fifth term. So to find a of 2, I'm going to use the previous term. So I'm going to use a of 1, and I want to add 7. All right, let's see if I can do math. Math's hard. So negative 24 plus 7, which is going to give you negative 17. All right, then a of 3, which means I'm going to use the previous term a of 2 and then add 7. So I want negative 17 plus 7, which gives me negative 10. Then a of 4, which is going to mean I use a of 3 plus 7. So I'm going to use negative 10 plus 7, which gives me positive 3. All right, now I need to go one more because I'm going to find the fifth term. So I'm going to find a of 5 plus 7. Nope, not a of 5. I'm going to use the fourth term, which means I'm doing 3 plus 7, which gives me 10. So a of 5 is equal to 10. All right. So now down here, we just want to determine if a series is arithmetic or not arithmetic. And then if it is arithmetic, what's the common difference? So as mentioned up here, remember, if we're multiplying, that's called geometric. So that's not arithmetic. Or if we're ever adding and the change is not constant, that's also an indicator that it is not arithmetic. So we're going to look down here. We're going to see what we got. So 5 to 8 plus 3, 8 to 11, plus 3, plus 3, plus 3. So this is a constant change. Which means it is arithmetic. And then our common difference here is a change of 3. All right, so now looking here at number 5, so we have a lot more terms. So here's the thing, you have to check every single term. So from negative 4 to positive 1, plus 5, 1 to 6, plus 5, 6 to 11, plus 5, 11 to 17, that's plus 6. Then plus 5 and plus 5. So all because of this little booger right here, all because that's plus 6, it's slightly different than the rest of them, automatically it's not arithmetic. And because it's not arithmetic, there's no common difference. All right, and looking at number 6 here. So from 100 to 90, we're subtracting 10, subtracting 10, subtracting 10, subtracting 10. So it's constant, which means it's arithmetic. And our common difference here is negative 10. All right, so that's the recursive form. So now we're going to look at what we call the explicit form. So the explicit form lets you find any term number. So our explicit form here, we have a of n equals a of 1 plus n minus 1 all times d. So we're taking the very first term, our term number, and our common difference, and we're going to find an actual term. So whether I have the first term and I want to find the 100th term, then you can use the explicit form. Because I don't know about you, I don't want to use the recursive form if I only have the first term and I need to find the 100th. Do you really want to write this out like 100 times? I don't think so. I don't know about you, I have better things to do. So that's where the explicit form comes into play. So given the arithmetic explicit form, we want to find the nth term given the following sequence. So down here, I give you a sequence and I want you to find a specific term. So here's the thing, you have to have your first term. So I know my first term here is 8. So this is my a of 1. Now I need to check my change. So from 8 to 12, well, that's plus 4, and plus 4. So I know it's arithmetic. Now that's my common difference. And then my n value, I want to find the 10th term. So that's my n value. All right, so now I'm going to start with the explicit form. and I'm going to plug everything in. All right, so I'm plugging in for this n value right here. I'm going to plug in for a of 1, plug in for n, and plug in for the d value right here. So what this means is I'm going to have a of 10, because that's the term I'm finding, equals my first term, which is 8, plus I'm finding the 10th term, so 10 minus 1, and then my common difference of 4. So we have our first term of 8, common difference of 4, and an n value of 10. So that's where everything is coming from. All right, so now I'm going to have a of 10 equals 8 plus 9 times 4. So a of 10 equals 8 plus 36, which is going to give you 44. Nope. So if you want to, what you can do, you can plug in this part right here into either a calculator, Desmos, or whatever, and you can actually get that value immediately. So you can actually skip that part and just go directly to here if you want. No big deal. All right. So for the next one, looking at number 2, so 36 to 30, it's going to be minus 6, minus 6, minus 6. All right, so we're arithmetic, so we're good. All right, so 36, this is my first term. So I need that for A1. And then I have 8 as my n value. So I know my d value is negative 6. So once again, a of n equals a of 1 plus n minus 1 times my common difference. All right, so I'm finding a of 8. So I'm going to find a of 8 equals my first term, which is 36, plus n minus 1. So I'm finding the 8th term, so I need n minus 1. So 8 minus 1 times my common difference, which is negative 6. All right, so you can plug that in, or you can do it by hand, whichever. So I'm going to do 36 plus 7 times negative 6. So a of 8 equals 36 minus 42. So a of 8 is going to be equal to negative 8. Nope, not 8, 6. I can't do math. Math is hard. It's fine. I'm only a math teacher. I can't do math. Everything's fine. Okay. So looking at this next one. So we're going to check to see if it's even arithmetic. So 4 to 9, that's plus 5. 9 to 14, that's plus 5. And 14 to 21, well, that's plus 7. So first off, this isn't even arithmetic. So you don't even have to do anything. It's just not arithmetic. So if you have a sequence that's not even arithmetic, you can't find the explicit form. It wouldn't even be a proper representation. So your answer here is just not arithmetic. All right, so now we're going to kind of change up the way it looks. So now I give you the first term, the common difference, and I want you to find a of 7. So it's really similar to what we have up here. It's just written differently. Instead of actually you having to go and find what everything is, I explicitly tell you what everything is. So here, we're still doing the explicit form. So a of 1 plus n minus 1 times the common difference. So I want to find the 7th term. So that's a of 7 equals the first term, which is negative 10, plus I want the 7th term times the common difference of 5. All right, so a of 7 equals negative 10 plus 6 times 5. So a of 7, which is negative 10 plus 30. So a of 7 is going to be equal to 20. All right, so I would suggest you pause here and actually try 5 and 6 on your own. Or not. So a of 1, nope, a of n equals a of 1 plus n minus 1 times your common difference. So I'm going to plug everything in. So I want to find the 25th term. So a of 25 equals a of 1, which is 4 plus 25 minus 1 times your common difference, which is 8. So I have a of 25 equals 4 plus 24 times 8. So we're going to have a of 25 equals 4 times 24 times 8, which gives you 192. I can do that, but I can't do 36 minus 42. Everything's fine. So a of 25 equals 4 plus 192, which is 196. So your answers could really vary. So even based on this, I could even scratch out 25 if I wanted to, and I could tell you find the 400th term. So you could find literally any term on the sequence as long as you have the first term and the common difference. If I really wanted to be mean, I would tell you to do it the recursive way, but I won't. All right, so now for number 6. So a of 1 is 10, your common difference is -6, and I want you to find the 5th term. All right, so I'm going to find the 5th term, so I'm going to find a of 5. So this is also really similar to function notation here, as you can see. So the first term, which is 10, then plus 5 minus 1 times our common difference, which is -6. So a of 5 equals 10 plus 4 times -6. So a of 5 is equal to 10 minus 24, which means a of 5, your 5th term, is going to be -14. Yeah, so really, if anything, it's just a lot of writing. All right, so these last two are some really kind of creative ones. Honors, these questions are more up your alley. On level, we haven't decided which ones you're going to be doing. Number 7 is fair game for everyone. Number 8 is really kind of the honors question. All right, so for number 7, so if the 5th term of an arithmetic sequence is 23 and the 6th term is equal to 27, what's the first term of the sequence and what's the common difference? So I give you 2 random terms in a sequence and I want you to find pretty much all the attributes of it. So think of this like a linear equation. So the 5th term of an arithmetic sequence is equal to 23, and then the 6th term is equal to 27. I'm going to write these as coordinates. So I know the 5th term is equal to 23. And then I know the 6th term is equal to 27. So I'm going to treat these like coordinates. So I'm going to kind of rewrite these as 5, 23 and 6, 27. All right, so if I want to find the first term and the common difference, well, the common difference is actually just finding the slope. So the common difference is the slope, which means I'm going to do y2 minus y1 over x2 minus x1. All right, so I'm going to do 27 minus 23, and then 6 minus 5. All right, so this is going to give me 4 over 1, which is equal to 4. So I know that my common difference here is going to be 4. And then I have actually 2 terms from my original problem. So now I'm going to start with my explicit form. And now I want to kind of work backwards. So I'm actually going to plug in 5, 23 for a value. So I know my fifth term is 23. So what this means is this is going to be my n, and this is my a of n. So instead of x and y, now we have n and a of n. So over here, so I'm going to have 23 equals a of 1 plus was my fifth term. So 5 minus 1, and then my common difference is 4. So now I want to solve this equation for a of 1. So I'm going to have 23 equals a of 1 plus 4 times 4. So 23 equals a of 1 plus 16. So that means I'm going to subtract 16 on both sides. So I'm going to have a of 1 is equal to 7. So that tells me my first term is 7, and I have a common difference of 4. So this is what I'm looking for. So just FYI, this is a really good question for pretty much anyone, just FYI. So I'd really make sure you're good on these problems, number 7 and 8. All right. Now number 8 is very similar. So now they're saying the 10th term is equal to 75 and the 12th term is equal to 89. So instead of giving you consecutive terms, now I'm giving you 2 random arbitrary terms. So the 10th term and the 12th term. So the 10th was 75 and the 12th I believe was 89. Yes. All right, so I'm going to start by finding the slope. So y2 minus y1 over x2 minus x1. So I'm going to write these as coordinates first. So this is going to be 10, 75. Then this point down here is 12, 89. All right, so I'm going to do 89 minus 75, and then 12 minus 10. All right, so in the numerator, we're going to have 14 over 2, which simplifies to 7. So that's our common difference. All right, so now I'm going to plug in for n and a of n so that I can get my first term. So I have a of n equals my first term plus n minus 1 times d. All right, so my a of n is 75 equals my a of 1 plus 10 minus 1 times my common difference, which is 7. So I have 75 equals a of 1 plus 9 times 7. So I'm going to have 75 equals a of 1 plus 63. Now I'm going to subtract 63 on both sides so I can find my first term. So a of 1 is equal to 12. All right, so my first term is 12, while my common difference is 7.